Hello everybody, welcome to this new chapter, troubleshooting methodologies. In this chapter, among the various lessons, we are going to read in how many systematic ways we can eliminate and eradicate the troubles. Okay, so the name of this lesson is systematic troubleshooting versus random checks. Now, in electric vehicle diagnostic system, troubleshooting methodologies are critical to accurately identifying and resolving issues in a safe, efficient, cost-effective manner. This is something everybody knows, but there are two contrasting approaches. Okay, there are two contrasting approaches. First approach is called systematic troubleshooting and second is random check. Now let's break down each in detail, particularly in context of EV diagnostic systems. The first is systematic troubleshooting, a structured step-by-step approach that follows the logical sequence based on technical data, diagnostic troubleshoot flowcharts, and vehicle system hierarchy. So this is a very structured step-by-step methodical approach. And what are the key characteristics? It is driven by the data and it is methodical. And it also follows OEM recommended procedure. Now this is usually when you say systematic troubleshooting, this is recommended by the OEM. And coming to the, it utilizes the fault code, live data, and service manual. It prioritizes root cause analysis. It uses tools such as scan tools, oscilloscopes, multimeters, and OEM software. Now, talking about the typical workflow. Now, let's touch upon the typical workflow. The first is a complaint verification. Confirm the customer concern. First of all, you need to confirm the customer concern. Next, you check the DTCs, and after checking the DTCs, you have to read codes via OBD2 or UDS communication. Document and interpret using the OEM code tables, and analyze freeze frame and live data, and view operating conditions at the time of the fault, and monitor battery voltage, temperature, current, insulation resistance, etc. Now next step is follow diagnostic flowcharts, and each fault has defined flowchart to narrow down the component or system. Okay, after the flowchart is completed, you perform the component subsystem test. That means you, by the help of use guided tests for battery modules, inverters, power electronics, etc. All right, also then you perform the repairs and validate. Okay, so in this last step you clear the codes and they ensure the vehicle returns to normal operation. All right, so this is a very important step. What is the main advantage of this step? Next is accurate diagnosis. It is reproducible and documentable. It minimizes warranty costs and downtime, and it supports training and auditability. Okay, these are the various advantages. Now, talking of the example, let's give one small example. EV not charging. If the problem is EV is not charging, what is the systematic process? First, you confirm the concern. Next, you retrieve the DTCs. For example, with the help of DTC, you identify that there is a charging system fault. Next, you check HV interlock circuit. Next, you inspect EVCE SE communication. I already explained to you what this acronym EVOSE stands for. Next, you perform charging control module tests and replace faulty onboard charger. Okay, so these are the systematic steps that you follow whenever a customer comes with a given concern. All right, now let's talk about the random check. What is meant by random check? And even random checks have their own advantages and disadvantages. We will see them both. What is the definition of random check? An unstructured trial and error approach where checks or component swaps are performed without clear diagnostic path. And structured trial and error approach where checks or component swaps are performed without clear this word is important, without a clear diagnostic path. And what are the key characteristics? So this is usually based on intuition, experience, or guesswork. Okay, so usually an experienced technician, with the help of some noise or with the help of some kind of jittery things that are happening in the vehicle, he will take a guess where exactly the fault is, and then he skips the formal diagnostic flow and may involve swapping components to see if the problem changes, and not typically aligned with OEM standards. All right, this is important. This is not exactly typically aligned with OEM standards, and usually this happens when you approach a technician who is not authorized by the OEM. All right. Now, what are the common behaviors? Common behaviors are checking the fuses, connectors or relays randomly, swapping HV cables, high voltage cables, battery modules, sensors without confirming failure, and using internet forums or anecdotal evidence for direction, disconnecting, reconnecting parts, hoping the problem resets automatically. So these are the common behaviors. But what are the disadvantages of this? What are the risks when it comes to this? Time consuming and inefficient, and high chance of misdiagnosis, and may escalate damage, especially in high voltage systems, not safe for high voltage environments, and no root cause identification. The only example or only advantage I see is if at all the technician is very experienced and he can zero in on the problem in a very expert manner, then he can save time. That's the only advantage as far as I am concerned. Now, for example, some EV voltage not charging, random checks might include replacing charge port, trying a different EVSC, swapping the onboard charger without reading DTCs, disconnecting the 12-volt battery to reset the system. So these are the various kinds of random checks. So we will see a small comparison table about the approaches, the tools, the safety, etc. So when it comes to approach, systematic troubleshooting means structured, data driven, and random check is unstructured trial and error. Now tools used: OEM scan tools, service manuals, basic tools, sometimes none. Safety: high users isolation SOP and low risks due to guessing. And when it comes to efficiency, systematic troubleshooting is a very is very high, and random check means efficiency is very low. And when it comes to training dependency, the technicians diagnosed in diagnostic flow often relies on tribal diagnostic flow, but when it comes to random check, they often relies on the tribal knowledge, or usually the knowledge which is prevalent, like word of mouth. So, and when it comes to root cause identification in systematic troubling, it is usually most of the time root cause identification happens. On random checks, it rarely happens. And when it comes to reproducibility in systematic troubleshooting, it is reproducible. I mean, you can go through the same steps for different scenarios, but when it comes to random checks, it is not possible. So when it comes to relevance to electric vehicles, in electric vehicles, especially with high voltage systems, complex ECUs, thermal management, software-driven logic, systematic troubleshooting is essential because safety is critical due to high voltage. Especially in electric vehicles, the systematic troubleshooting is extremely important and extremely recommended, highly recommended. Now, when it comes to random checks can cause serious damage or even personal injury. Now, uh, software faults require diagnostics. Example, CAN logs, software versions, and calibration. Now, when it comes to battery faults, they need balancing on monitoring, logic, understanding. And next is interlock and insulation monitoring systems can falsely point to the hardware. Okay, so this is relevant to the EV. So in summary, when it comes to systematic, it is used when dealing with complex or high voltage system, and time is extremely limited and risk is low. But when quick, sorry, in systematic is usually avoided when time is extremely limited. But when it comes to random check, quick checks are known simple issues, and it must be avoided when in any safety critical or software driven system. Thank you.